When I originally started here, almost none of the generators that we had running had safety features on them, such as oil cutoff and hot water sensor. None of that was working, and that reason for that was the control boxes that we received with these generators, which is that there, were they're just a bad unit. I think the switch used to go out in a week, literally brand new 1 week, and that was needing replacement. But the whole wiring harness and the control box were a problem, and I believe that was just because they were built for shipment rather than for long-term use. But anyway, so that was the problem, was those control boxes. So I went and designed a simple mechanical or electromechanical control box. So you got your power, that there's a fault light, you had a button for starter, the crank, and you had a button for the glow plugs. It was really simple. Just use one relay as the the safety, so that when the oil pressure dropped or the water temperature got too high, it would shut down the engine. Sorry about the noise. With this new Arduino controlled engine start box, you now have a real quick way to check for problems. Right now I'm looking at the voltage meter. Now that's in between the 14 volt and 14.8 volt range. You know you've got a good electrical system, both battery and alternator. So that's a quick check you can do just walking past the generator. Another one, come over here to the return line from the generator. I think you can see that. If that fuel is pouring back into the into the fuel tank at a good rate, you know you've got a good fuel system. That's really important in winter time, because a lot of times looking in here will give you an indication whether your fuel filter's blocked up or gelling up, and you can replace them out before they actually cause the engine to shut down. Okay, when using this in manual start mode, it's just a matter of flick on that switch. You get a voltage indicator. At the moment you'll see it says 13.8 volts. That's okay because the engine's not running. That's a good high battery voltage, so that's fine at the moment. And you just press this switch here, and that starts the start process. I don't know if you could see that little first LED that come on. That is the glow plugs, indicating that the glow plugs are heating, and then that'll go off, and then the crank will start. The starter will start to crank the motor. And you'll see the voltage has now come up to 14.5 volts, which is a good running voltage. Okay, this is in auto start mode. Same deal. You see the battery voltage 13.1. That's still a good solid battery voltage when the engine's not running. It's now cycling through the glow plug, soon to go to starter motor. Okay, so it has started. Now it's in a warm-up mode. 2 minutes from now it'll actually engage the three-phase power to the well pump. So this gives the engine time to warm up before loading it up too much. I don't know if you can see it. One LED on at the moment. That's the run LED. Just down there. And in 2 minutes time you'll have the load LED come on everything will be functioning then. And then the second relays come on, and that's what controls the generator head to the well pump. I'm going to redo this just for sake of being able to hear it. So you've got your voltmeter, you have your relay control board, you have your Arduino, and some power supply, a power regulator. I talk mostly about Arduino, but Arduino is really just a part of embedded systems or the Internet of Things. Arduino is a programming language, and it's also often used to refer to these boards. So what the board is a development board. So what that's made it very easy to do is to build or develop projects that before would have required a lot of eggheads and a lot of money building electronic circuits and programming computers and whatever else they need to do to build something. But whereas something like this can be designed and built on your kitchen table. Embedded systems and the Internet of Things is pretty much the buzzword. I don't know if that's the right terminology, but everyone's talking about it. Embedded systems have been used for a very long time. You know, your microwave has an embedded system, you know, an embedded computer in it, and most stoves and washing machines, even a flashlight has a microprocessor controlling it, an LED flashlight. What the Internet of Things is simply connecting those embedded systems to the internet or to another network. And you hear all the talk about smart homes and smart meters, and everyone's got their smartphones. That's all Internet of Things devices. Okay, so right at the moment, this is set up to control the engine, and it also gives me the ability to control the well pump. So what that means is that I can save a lot of money in fuel. For example, when for whatever reason the cows aren't drinking as much water from the tank, whether it is, you know, due to weather, you know, we've had a rainstorm and they're drinking on puddles, or they've drifted over to another water tank, and all of a sudden there's not as great of a need on the tank that this generator is running. With sensors in the tank, which is just fancy word for float switches, we can use that to control the pump, you know, utilizing the Arduino. And so that's going to save, for example, when one of these generators is running and driving a pump, it's normally using about 6 gallons a day, maybe 7, depending on the size of the pump. When it goes into you know, this standby mode where it doesn't need to be pumping water, it'll be down to $2 a day. Now that's, right now I'm just talking about the quick and easy shutting off the generator head from the well pump to save water there. It's just to save fuel and water. way I intend to use this is with probably a 24-hour period of time. It'll use the simple generator head shutdown, because you don't want to be starting and stopping these generators all the time. But let's say after 24 hours the cows still haven't drunk down this water tank, then the generator can shut down and go on to a standby mode, and restart again when the need is there. Different types of wells. We've got a lot of different types of wells, and it's, if you can imagine, they behave just like water above ground. Some are like rivers. They seem to have unlimited amounts of water, you know, never seem to go dry or draw down too far. Others are like little tiny streams, which you know, we barely have enough water to, you know, you start them up and they draw down to whatever that little stream flow is, you know, whether it's 7 gallons a minute or 5 gallons a minute. There's others that are like ponds or you know, reservoirs of water under the ground, which are filled by a little stream. So what happens is we get in there. What we've done in the past is we've gone into these types of wells and we've pumped them. We've brought all that water from below ground to above ground, overflowed it onto the ground. It's seeped into the ground but not back into the aquifer, and it's evaporated from the ground, or it's run down gullies and soaked into little mud puddles. And so effectively in the past we've wasted that water that's underground, which is a shame because it's a huge emergency reservoir. One of the most, the well that comes to mind as being the most like that is probably 5 Mile. So it starts out at a really good pump rate, and then after several weeks it drops down to a fairly low pump rate, and it stays at that until the next year. So using the Arduino control mechanism, we can stop wasting water, putting it out into you know, leaky dirt tanks, or you know, running it down the ditch. So that's saving fuel, and it's saving the water for when the cows need it. The costs of the Arduino you know, controlling of the well systems and other things is pretty small, I think. Generator control box, which is that thing there that you saw earlier, is about $50 in parts. Doesn't include my time putting it together, which was quite a bit, but that would come down with building more of them. So yeah, just roughly, I mean, about $10 for the enclosure. I think it was $5 for the monitor. Yeah, $5 to $10 for the board, for the Arduino board. $10 for the relay module, and yeah, bits of wire and regular whatever. It all comes up, as far as parts are concerned, very cheap. As well as the generator control box, I need certain parts to actually fit to the wells. It's time consuming to do all the setup at the well, to you know, put the sensors in the tank and whatever else I need to do at each particular well. Each well will be different to some extent, but anyway, so well parts will be things like this. That's a float switch, a sensor, okay, and wire. And this thing here, that's a 3-phase solid state relay. We've actually used this for a couple of years now up at Schoolhouse Canyon to control what's going on up there, and that's worked amazingly well. And that there, I think last time I looked it was $18, but you've got to wait for it to come out of China. So if you buy it here, I think we looked and it was like $100. So anyway, that's the sort of thing we need at each individual well that we want to do any amount of Arduino control with. Labor, that's, like I said, more setup time required, but I pretty much only have to do it once, and once it's set up, that should be it. It's just then a matter of maintaining it. Alright, the savings from the Arduino control, I think I mentioned earlier, the difference in fuel consumption on a standard, on the way we've been doing it in the past. 7 gallons per day is a pretty normal generator usage. It varies between 5 and 8, but anyway, that's a pretty standard usage amount. So 7 gallons per day in fuel versus 2 gallons per day if it goes into the first standby mode. Maintenance, if it's spending a lot of time in standby mode, it does not need to be all changed every week. So we might be able to skip it out to bi-weekly. Fuel consumption wise, we'd probably go close to 3 weeks on an oil and fuel change if the generator isn't actually being used. And it actually should be a lot more than that, because if I use it the way I want to, the generator will actually shut down after 24 hours and be saving much more fuel and oil than even that. Wear and tear, mechanics that work less last longer, and that's just plain old common sense. If they're not working hard, or if they're working for less time, they last longer. With the water, it's hard for me to put a value on it as to what our savings are, but we live in a desert and the savings would be substantial. I mean, we see the cows all the time, wishing we had more water. So whatever water we save is money in the bank. Other considerations, comms. I have managed to send and receive data through our ranch radio net. It's just real simple, but gives me, that's actually the board there, that little tiny add-on there gives me the ability to send or receive information or instructions through our company radio net. It's still got bugs, I'm still working on that, but anyway, that's something else that's coming in the future, and definitely be able to have it by this summer. That comes into monitoring as well, just being able to keep an eye on the water level, or whether a generator is running. We can do all that via the radio, and later on hopefully through a mesh network, which is all the generators and other hubs communicating through each other. And then usability. Somebody mentioned that it might be too complicated, but the whole idea of an embedded system, which is what this is that it should maintain a it should be usable in almost exactly the same way as it was before, and it does that. So anybody can walk up, press a button, or flick a switch, press a button, start a motor. In fact, it's easier now than it ever was. As far as the setup and the wiring and the electronics, I know at least Marty and Brian both have that sort of a background, so it's not that hard. I mean, it took me a long time to learn the programming, but the actual setting up and wiring is very simple and easy to follow, easy to copy.